If you've tried to simulate additive manufacturing in Abaqus and wondered how material is actually added over time, this video will finally make it click. In the next few minutes, I'll break down the birth and death technique step by step, no theory overload, just a clean workflow that actually works. First, I'll explain the overall strategy behind it, and then I'll walk you through one complete example from start to finish. If you want to skip the simulations and download the files directly, check the pinned comment down below. Are you ready? Let's get started. Before jumping to the example, I'm going to review the strategy of the elementary activation or birth and death technique in details. Step 1 is partitioning, but what does that actually mean? It means instead of having one long partition like this, we split it into smaller chunks like this. To have a better sense of it, I'm going to the assembly here. Imagine this is our model. Since this is additive manufacturing, we have a substrate, which is this one, and we have a layer, which is this one. The layer, instead of being one long continuous part, must be partitioned into smaller segments. For example, I'm splitting it into 4 chunks. The rule of thumb is the more partitions you have, the smoother your heat flux transition will be. But to keep it simple today, we'll stick to the 4. Step 2 is calculating the step time. You need to divide the total welding time or additive manufacturing time by the number of partitions. In our case today, the total welding time is 20 seconds and we have 4 partitions here, so each step would be 20 divided by 4. That means each analysis step will last exactly 5 seconds. So here you need to have 4 steps here. Step 1, 2, 3, and 4, and each step is 5 seconds. You need to have one step in the beginning, which is called death. In that step, all the elements are deactivated and each step would reactivate the corresponding partition, and we would have a cooling step as well. Step 3 is very crucial. If you mess it up, your simulation would go wrong. You need to create bunch of sets based on your mesh. So let's go to the mesh, and if I go to the part, then tools, set, manager, as I show you here, we have different bunch of sets. So set 1 is the first partition containing all the elements, set 2, set 3, and set 4. Later on, we will need those to activate the parts. I will show you exactly how to create these sets in the practical example coming up, so I won't waste time on the details right here. Step 4. We need to make an interaction for element activation. So I close this one. I go to the interaction. Here in the interaction manager, we need to create different interactions. The first one must be in the step death. I put all the elements in the deactivated mode. So as you see here, I deactivated them in the step and the region must be selected. So I selected all of the parts and the region type is elements and it is deactivated. Then in step 1, I created another interaction. I selected the mesh set I showed you in the previous step, and I click here to reactivate it in this step, and I do the same for step 2, 3, and step 4. And the last step is optional. You can create some local coordinates like this in the middle of every part, and when we create the loads, we can select those local coordinates and we can use the equation for them. This would be helpful if we're not using the deflux subroutine, so that we can refer this one as the center of the flux. I'll show you one field equation here. As you see here, we have one equation here and we selected the local system. I mean this one, instead of this coordinate we have to be the center of our flux, and we have the equation here instead of using the subroutine. This was the whole strategy. Now I'm beginning to explain things in details for you. I know it was a little fast-paced, but I'm going to take things slow from now. Before we begin, if you enjoyed this video so far, please like this video, and if you have a question, drop it in the comments down below. Let's continue. Part. Create part. We want to create the substrate first, then we create the layer. The substrate should be 3D deformable solid extrusion, and this guy can be 0.1. We create a rectangle like this. and we add the dimensions. So this guy can be 0.006 and 0.05. Okay, done. And we want to extrude it with a number of 0.12. So this is the substrate. Now we're going to create the layer. So layer, solid extrusion 0.05. Now we create another rectangle. This should be 0.002 and this should be 0.012 and it should be extruded 0.04. So this is the additive layer. Now it should be divided into some parts. So partition cell, define cutting plane, 3 points. We divide it from the center using these 3 points. Now we want to divide each of them into 2 parts. So like this, and scroll button each time, you can go faster. Now we have our additive manufacturing layer divided into 4 parts. Now it's time to go to the property. Now we want to create separate properties for layer and the substrate. So I start with the layer from general density. We use this value of density. Now we can go from thermal conductivity and copy and paste these values, but first we have to check the use temperature dependent data, and from thermal specific heat, again use temperature dependent data. Now we copy and paste the specific heat and the temperature. It's better to be Inconel 738, and now we want to create one for the substrate, which is the steel. General density, we have this value, copy, paste. Thermal conductivity, temperature dependent data, thermal specific heat, temperature dependent data, copy and paste. So this is okay. Now we want to create a section. This is the substrate section, solid homogeneous. Now we choose the steel for the substrate, and we create one for the layer, solid homogeneous again, and we select the Inconel 738. So we want to assign the sections. So this part, uncheck this one in order not to create too many sets. And this is the substrate. Now from here we go to the layer, we select it, we assign the layer section to it, and that's okay. So everything is done here. Now we want to move to the assembly. Now we create our instances. We first create the substrate, hit OK. Now we want to translate it to the 0, 0, 0. So I click on this one, scroll button, this point should go here, and scroll button again. So I reset this, and I want to create the layer. So this is the layer, okay, but I want to translate it. So first I translate this one from here to here, hit OK. Now from this one, query information, pointer node, I zoom in, I select this one and click OK. It gives us the coordinate. Control C, we can copy that, and we want to translate this one to here. So translate instance, we select this one, scroll button. Now I select this one, which is the center of this layer, and I paste it, but in the Z direction it should be 60. So this is 60 in the Z direction. I click enter, okay. Now we have our layer in the middle of this substrate. Now we're good to go to the next one, which is mesh. Here I would like to go to the part and the substrate. We want to create one path on this one, so I click on partition face sketch, select vertical right, and create two lines here and here, and each of them should have a distance of 0.19 from the sides. This one is okay, and this one should be okay, and this guy should be 0.012, which is the same as the width of the layer. Okay, enter, and we delete this one. Now we don't want any purple thing here. Click on down. Now this is created. Now it's time to sweep that, so left click, hold, and come here to the extrude / sweep. I select this one, scroll button, sweep along edge, this one, create partition, another time here, this one, sweep along edge, this edge, scroll button, and down. So if we rotate this instance, we see this layer is extruded here. Okay, escape. And if we look at it in the assembly, you see these lines are created. Alright, now it's time to mesh this layer. See the edges. I select all of the edges, done, and by number, click on 4, okay, done, and mesh. Now we have a mesh here, and we want to go to the substrate. Now this part is kind of tricky, so if we want to mesh this one, we should select every line parallel to the length of the layer. Okay, we select that. This value should be 48. I will tell you in a second. If we mesh and we go to the assembly, we see that each line coinciding here. This one we have 16 elements on this one, and the length of the substrate is 3 times higher than the layer, so the mesh should be 3 times higher in the number. It should be 16 times 3, which is 48. But now we want to see the edge. I would like to delete the mesh. Now we want to rotate, select by holding shift. We can select every line, and we want to create a bias. So I click on done. We have bias, we can have single, and we want to flip a couple of them, which are this one, and done. You see the arrows should face toward the center, and we can have 5, and we mesh the part. Yeah, it's not bad, it can be better. Okay, now we have assembling. As you see, these lines should be in line with each other, which is pretty important. So the next thing is to go to the layer. Now put this one on cell and select the first cell, replace selected. So we want to create some sets. We should go to the set manager, create set 1. It should be element. We select all the elements, scroll button. Now we replace all, and we repeat this for all layers. Okay, as we see here, we have set 1, set 2, set 3, and set 4. We want to create another set. We say layer, elements, continue. We select the whole layer and we click done. Now we have another layer. Now we can go to this step, create step death. If you don't know what is the birth and death technique, you can see the video on top right here to have an idea. Okay, this should be heat transfer, step death. The time period should be a pretty small one, 0.1, and we can have 0.01, 1e minus 20, and this one 0.1 is okay, and this one should be 350. Okay, now we go to the step manager. Step 2 should be 5 seconds, and this one should be 0.01, 1e minus 20, and 2.5, which is half of the time we have. And this one should be 350. This should be 1000. We create 3 more steps which are exactly the same as step 2. Okay, the step is completed. Now it's time to go to the interaction. We want to create an interaction here from the model change in the step death. Continue. Now we want to have this one deactivated. Put this on element. We select from sets, layer. We select all layers and we say that this one is deactivated. Now we want to create another one, model change in step 2. Again, elements. Now we want to select layer 1, set 1, and we have this one reactivated. We create 3 more interactions which are pretty much the same for other layers, and it should be something like this. As you see, if I click on this, you see which part is selected. Now it's time to create the surface film condition interaction. Okay, I put this one on cell. By holding shift, I can select this one, and I want to remove them. Now we go to the create interaction, surface film condition, and it should be on step death. You can say surface film still. Continue. Now we select literally everywhere and we rotate the instance. Click escape. By holding control, we deselect the bottom part. Okay, we want to select this one. The film coefficient should be 10 and the sink temperature is something like 25. As you see, the interaction is created. Now we want to select the layer, so we remove the base metal. We create another interaction, surface film condition, and we select this one. Okay, we click on done. This time it should be 242 and the sink temperature is 25 again. Okay, renamed to surface film in Connell. There's another interaction that should be selected, but before that we want to go to the model and edit attributes, model 1. Absolute zero temperature is minus 273.15 and the Stephen Boltzmann constant is this one. Control C, Control V. Okay, now we can create the surface radiation. So let's name it surface radiation. Continue. This time we want to select everywhere but this bottom part. Okay, 0.7 and the ambient temperature we say 20. Now the interaction section is over. It's time to go to the load. So we want to create our own distribution on each layer. So we want to create some datum points. From tools, we go to the datum. Midway between 2 points, we select these 2 points and we see that a point is created in the center, and we select these 2. Okay, it is created. Now we want to create our own local coordinates and apply the load on those local coordinates so that we can have a distribution. So here we click on this one, we create another one. Yeah, we have our datum here. We have to do that for all other points we have here for local coordinates. Okay, now it's time to apply the load. Load 1, surface heat flux. We select this surface, we click on done, and the magnitude 1.25 E7, and here instead of the normal distribution we want to create analytical field. So analytical field, We click on continue. Now we want to input the flux distribution equation here. In this Excel file, I have the equation. This is the equation in the syntax of Abaqus. Okay, we put it here, and now we want to select the local coordinate. This is the coordinate we have, and I click on OK. Now we want to select this one here. It is OK. Now we want to create other loads, and we have to keep in mind that we have to select each coordinate in each step, and we want to deactivate it, this one, after it's done. Now the steps should be like this: step 1 here, step 2 here, and make sure to select everything correctly. It should be like this. Alright, everything is almost done. Now we want to go to create a predefined field. Step initial, and it should be other temperature. We select everything and we say 25. Okay, now there are a couple of things that we should do. First, we go to step and create a cooling step. So after step 5, it should be cooling 420, 0.01, 1000, and it can be 220, 350. We click on OK. Now it's time to go to the load manager. We want to deactivate this one, and from the mesh we go to the part and we want to assign element type. Select everything, scroll button, and this should be heat transfer, convection / diffusion should be turned on, and from the substrate we do the same, heat transfer, convection, diffusion. Now everything looks good. We can go and create the job. So I would like to name it SLM, continue, OK, submit, and yes. Now I come back after the job is completed. Job is completed. Let's go to the result section. Put it on this one, and here nodal temperature, and see how it goes. Yeah, as you see, the flux is moving. In order to have a realistic one, we want to make it slower and see how it goes. Yeah, this is the movement of the flux, because we created local coordinates and also we created the expression for the Gaussian distribution, and here you see that the shape of the molten pole is visible here like this. As you see here on the last part of the step, we can go and check the temperature. From here we go node and probe value. We can see every node we want. Here it says that the maximum temperature is 1700, while here is way different. We can also create a plot. So from here, create XY data, ODP field output, continue, and from the unique nodal, you can have the nodal temperature, and you can edit selection. So you can pick it from the viewport by holding shift, click a couple of nodes, and you can plot that. As you see, here is the plot of temperature versus time. This node has the highest temperature, and also this plot is so useful. You can calculate the cooling rate from this one. Congrats on completing the birth and death technique. If you want to take your additive manufacturing skills even further, click on the AM masterclass on screen before it ends, and I see you there.